Homework Hotline, what is your emergency?
Hello, you are watching the Homework Hotline. I'm Becca, a math teacher at Emily Griffith High School.
Welcome. My name is Nathan, and I'm also a math teacher at Emily Griffith High School.
Are you having problems getting a math answer? Well, that's why we're here. We'll take you through each step so you can see how to solve the problem.
We're here every Tuesday and Wednesday from 4:30 to 5:30 p.m. You can give us a call at 720-424-1666. We love taking your calls, and talking to you on the phone helps us answer your questions a little bit more thoroughly.
You can watch our show in several different ways. For live broadcasts, you can watch us on Comcast Channel 22 or go to livestream.com and search for EG Homework Hotline. If you would like to see some of our past shows, watch us on YouTube by searching for DPS TV Homework Hotline.
The Homework Hotline is sponsored by Emily Griffith High School. One of our students, Lily, is also a part of our team. Lily, tell the audience about yourself and what you do on the Homework Hotline.
Hi guys, I'm Lily and I'm a senior at Emily Griffith High School. Homework Hotline wants to be accommodating to those of you who turn in your questions on social media, and I try and get those questions over to Nathan and Becca. I am also the trivia queen, and at the top of each show I will ask you a trivia question, and before the end of the show I want to hear an answer from you guys. The trivia question can be on any subject, and if you answer the correct answer, then you will win a prize. And so today we have an animal question. So today's trivia question is, what group of animals other than humans are capable of hurting other animals and are capable of farming? And we will answer that at the end of the show.
So if you have an answer to that, or if you have a homework question, our phone number is on the top right of your screen. It's 720-424-1666, but I'd also like to give you some other ways to get a hold of us because, as Lily told you, she manages the social media. So in order to get a hold of us via social media, you can go on Facebook or Twitter at EG Homework. That's where you can send your questions. You can text us if you'd like to, even at 970-680-3771. Or if you'd like, you can email us at homework@emilygriffith.edu. So we'll be here until 5:30 today, so this is how you can get your homework questions answered or also answer that trivia question if you think you might know. And get a prize for that one too. So, all right. So in the meantime, let's go to Lily and get some questions from social media answered.
So this is kind of written weird, so I'm sorry if I sound a little wordy, but it says, find the measures of two supplemental angles if 5 times the measure of one equals 2 times the measure of the other, negative 59 degrees. Hopefully that made sense.
It's a geometry kind of algebra question, so I can take that one. Again, I think we've seen a lot of these questions. A lot of them appear to be, really tricky because of the way they're worded, especially when you try to type it on the internet. It's a little bit more challenging to type. So the hard part about these is, again, kind of just setting them up. So we are looking for the measure of two angles, measure of two supplemental angles. If 5 times the measure of one equals 2 times the measure of the other, minus 59 degrees. So again, it's kind of a wordy problem, but if we just think about it step by step and break it down, it becomes a little bit more manageable. So I'm going to go ahead and start writing this out, what I'm reading. I'm looking for the measure of two supplemental angles if 5 times the measure of one angle. So before, we're looking for two different angles, so I'm going to call this whatever, I'm going to call it X and Y. These are the two angles I'm going to say we're looking for. So we're saying that 5 times the measure of one angle, so 5 times x, is going to equal 2 times the measure of the other angle, minus 59 degrees. And just looking at what I have here, this really isn't going to be enough to solve the problem, because what we have here is 2 variables and only 1 equation. But we do have a little bit more information that says this is 2 supplemental angles. So going back into geometry, we should know that 2 supplemental angles add up to 180 degrees. So if I look at something like this, I should know that I'm going to have an angle, we'll call it angle X, and angle Y. these should add up to 180 degrees based on some of our vocabulary. So I can actually write another equation here, and I can say x plus y, our two angles, have to add up to 180 degrees. So now I have something that I can work with. I have two equations and two variables, so I can solve for each of these variables. So first thing I need to do, and there are a couple ways to do this, but I think the easiest way is to rewrite these equations, one of these equations, so it's in terms of the other. So in this case, I can actually subtract y from both sides, and then I'm left with x equals 180 minus y. So I'm going to use this equation here, and I'm going to plug this equation back into my first equation. It was a little bit more complicated. So anywhere there's an x, for example, right here, I'm going to plug this back in. So I'm leaving everything else the same, 5 times, and we said x is 180 minus y over here. So x is 180 minus y equals 2y minus 59. So now if you look at this, I've kind of resolved the issue that there were two equations, and now I'm down to just one. And I can just go through now and simplify and solve from there. So I'm going to distribute 5 times 180. It's going to be 900 minus, I'm still distributing, 5 times negative y, so minus 5y equals, and everything else is I'm leaving alone right now. So to go from here, I'm just going to, again, continue simplifying and combining my like terms. Ultimately, I'm trying to isolate y over here. So what I can do is I can add 59 to this side and add 59 to this side. And I get 959 minus 5y equals 2y. And continue solving, combining my like terms. I get plus 5y here, plus 5y here. And I have 959 equals 7y. So from here, again, we're solving for y, so I need to isolate. This operation here is 7 times y. So I'm going to go ahead and do the inverse operation of dividing by 7 to get that y by itself. And I might need a calculator for this part. So 959 divided by 7 is 137 degrees. So y equals 137. Oh, let's 5. 137 degrees. So I want to find the measure of both angles, actually. So what I know is x plus y, both of my angles have to add up to 137 degrees. So I'm actually going to redraw this here because it doesn't quite look right. So angle y looks like it's probably this angle, 137 degrees. Now I just need to figure out what angle x is. I can do this one of two ways, but I'm going to go back to my original equation up here, where we said x plus y equals 180. Well, now I know that y is 137 degrees, so I can solve this simpler equation. Just subtract 137 minus 137, and x is going to equal 43 degrees. So coming back over here, x is 43 degrees. So again, really kind of when you read this problem, it sounds pretty complicated, but when you actually start to break it down, I think one of the good strategies here is read the problem a little bit more slowly and try to write everything out into an actual equation, and then think about what you know with just supplemental angles or just different characteristics of angles and try to come up with a second equation.
Awesome. Well, we got a great start to our day answering some questions. Just a reminder, if you have any homework questions today, call us. Any issues, anything that we can help you figure out, call us live right now. The phone number's on the top of your screen, and we can help you answer those questions. So let's go back to social media with Lily and get another question from there answered.
Okay, so we're looking at the top one, and it asks, Tom travels 60 miles per hour going to a neighboring city and 50 miles per hour coming back using the same road. He drove a total of 5 hours away and back. What is the distance from Tom's house to the city he visited? And it says to round to the nearest mile.
So, okay, so I'm going to write down, this is a distance, rate, and time problem. So I'm going to record some information here real quick first, just to make sure. So let's say he travels 60 miles per hour going there and 50 miles per hour coming back, and using the same road, and then his time, total time was going to be 5 hours? 5 hours. And we need to know the distance. Okay, so distance. What distance is? So 5 hours. And then we are finding distance. Okay. So I've got all of the information recorded. Let's kind of start sifting through this. So one thing that we want to remember is that distance, rate, and time. The relationship between that is that the distance always equals the rate times the time it takes to get there. So we'll just use this information to kind of help us work through it. So that being said, if we were to, because this kind of key information here that we know our total time, that kind of tells us that we should possibly isolate time in this equation, because that's really what we're going to kind of be working through. So what I would do with this equation is divide both sides by the rate. And all I'm doing is rearranging that equation. So now I have time is equal to distance divided by the rate. So we're going to use that there. So I know that my total time, and I'm going to call time 1 plus time 2. I'm going to call time 1 the time it takes to get to where I'm going. And then time 2 is the time it's taking to get back. And I know that altogether that is supposed to be 5 hours. I also know, so if I set up time 1, so thinking of 1 as my trip there, I don't know the distance, but we can call it D. But I do know my rate, and my rate is going to be 60 miles an hour. So I can say the time it took me to get there is whatever the distance is divided by 60. I can also say that time 2 is, so the time it's taking for me to get back from the trip is going to be whatever my distance was divided by the rate on the way back. So the rate on the way back was 50 miles an hour. So D over 50. And what I want to kind of point out is that I'm using the same distance, D and D, because if you are traveling on the same road, so let's say I was starting at point A here, and I traveled all the way to point B, and then I traveled back to point A, so point A and point B, that distance is the same. So my distance for the first part of the trip and distance for the second part of the trip is the same. And so therefore they're equal. And so I don't need to label D1 and D2 two different Ds. I can just use one of them because it's going to be the same distance. And this is actually what we're finding, if you kind of remember correctly. We need to find out what this D is. So we're going to use a little bit of a systems of equations approach where we're substituting in, using this idea here, where the time it takes there plus the time it takes back is going to equal 5 hours. I'm going to replace my T1, or time, with this equation here, or use this equation to replace it. Instead of calling it T1, I'm going to call it distance divided by 60, because that's what T1 equals. I'm just substituting in. And then time 2 is going to be distance over 50, so I'm just going to replace T2 with D over 50. And we know that those are supposed to add up together to give us 5 hours. So at this point, this is kind of what one of our goals was, is we want to get an equation with one variable, because that's something that we can take care of. So when you have equations that have fractions in them, not everybody loves fractions. I use a little trick to get rid of the fractions, where you multiply the entire equation by the common denominator of 60 and 50. And that common denominator would be 300, because 300, you can multiply 50 to get 300, and you can also multiply 60 to get 300. So what I'm going to do is multiply my entire equation by 300 to get rid of those fractions. So what ends up happening then is for that first term, I have 300d over 60, which just simplifies to, what does that simplify to? I'm just going to use this really quick. It's going to be 50, or 5d. So that's going to give me 5d. And then the second term would end up being 300d over 50, which is just going to give me 6d. And then 5 times 300, which is 1,500. Now we just have to combine like terms and get that d by itself. So we get 11d equals 1,500. And then dividing both sides of our equation by 11 to get that d by itself. We have 1,500 divided by d, and I'm going to use my calculator here too, because that's not a very nice even number. You end up getting 136, and I believe the question said round to the nearest tenth. So 136.36, I'm going to round it to 34, and that's miles. So that's what we had to figure out, is distance. These distance, rate, and time problems are never really simple. They're not really all that easy. But what they really kind of focus around is this equation here, that distance equals the rate times time. And if you can kind of, what I do is I end up writing out my the information that I know, and then you try to figure out, well, what is the same in both situations, and possibly come up with some kind of equation based on the relationships between anything that's given, and then just fill in the blanks from there. So they're really not all that easy problems, but that's an example of how to solve one.
Yeah, it looks like a lot of work.
Yeah.
Hopefully you have a lot of paper whenever you do problems like that.
They always stump me at first. I have to kind of sit there and play around with them at first, but.
All right, so we're going to go ahead and give you our contact information once again. Again, it's always easiest to give us a call. We can answer your questions individually. You can give us a call at 720-424-1666. You can also reach us on a couple of social media sites like Facebook at EG Homework, or on Twitter, also at EG Homework. You can send us a text message at 970-680-3771, or an email at homework@emilygriffith.edu. But again, the easiest way to contact us right away is just give us a call at that number on the top right of your screen right now.
When you call that way, lets us make sure that we are actually helping you, and that you understand what we're explaining to you and whatnot.
It's a bit more interactive, so
it is,
I think when we're just answering a question, like there are parts that some students might get hung up on, and it's really helpful for us if you can clarify.
Absolutely, absolutely. All right, well, let's go get more social media questions answered, since we have no callers at the moment.
All right.
Okay, so this one says a rectangle field has an area of 300 square meters and a perimeter of 80 meters. What are the length and width of the field?
Looks like another geometry question, so I can take that one.
You got it.
So this is going to end up being another systems of equations type problem. What I like to do with these is always, I think, if you draw a picture before you do anything else, makes it a little bit more clear. So what I'm doing on my board is I'm just drawing a picture and really just writing down all the information that I have. So I've got a box, like this is pretty much as good as my rectangle field is going to look. And it's got an area of, we'll call it A, of 300 meters and a perimeter of 80 meters. And we're looking for the length and the width of this field. So I'm going to go ahead and label my picture here, length and width. So a couple things you need to think about is, first of all, what's the equation for the area of a of a rectangle, and then what's the equation for a perimeter, and we're going to use both of those to solve our problem here. So if you remember, the area of a rectangle is going to be length times the width, and then when we're talking about the perimeter, we're really talking about, again, if you were to either put a fence all the way around this field, or you were to just, you know, start at one point and just walk all the way around the field. How far would you walk around? So when I look at perimeter, I need to consider the length of both sides and the width of both sides. And the perimeter is going to be, you can write this two ways. It's the length plus the width plus the length plus the width. I would prefer to write it as 2 times the length plus 2 times the width. So we have these two formulas here. We have the area is the length times the width. It's getting a little messy. And we have the perimeter is 2 times the length plus 2 times the width. So we also know a little bit more information. We know the area is 300 meters and the perimeter is 80 meters. So I'm going to come over here and write these out. 300 is the area, so that's going to equal the length times the width. And the perimeter is going to be 80 equals 2L plus 2W. And again, similar to the last couple problems we did, where we basically need to rewrite one of these equations in terms of the other. So because I think this one's going to be a little easier, I'm going to rewrite the second equation with the perimeter. So all I'm going to do, I can choose either one, it doesn't really matter. I'm going to rewrite this in terms of W, so I'm going to solve for the length L. So I'm just subtracting 2W from each side, and I get 80 minus 2W equals 2L. And again, since I'm solving for L, now I just need to divide by 2 on each side. And I'm left with L equals 40 minus W. So this is my equation for L, and I'm going to use this now to solve my other equation for my area. So all I'm doing is coming back over here to my other equation, 300 equals, and now I know L in terms of W, so 40 minus W times W. And then what we need to do is just simplify this. So 300 equals 40, again, distributing here, 40W minus W squared. And this becomes a quadratic equation here. So I'm actually going to, when we're solving quadratic equations, it's helpful to have the first term, the squared term, as a positive number. So I'm going to move everything over to the left side now. So I'm going to subtract 40W, and I'm going to add W squared. And what I'm going to be left with is W squared minus 40W plus 300 equals 0. Okay. In quadratics, we've talked about a few different ways to solve, either using the zero product property or possibly quadratic formula. I don't know. Can you see an easy way, Becca, to factor this, or do you think I need to use quadratic? Kind of a messy quadratic formula problem.
300, well, let's see. I have
Let's see. So all we're really kind of doing right now is thinking of all the factors of 300 and seeing if I can sum them up to, no, nothing.
15 and 20 was close, but it's going to be negative, so let's try this one.
Oh,
here.
30 and 10. 30 and 10 would work.
Yeah, 30 and 10.
All right.
Well,
so,
and negatives, both.
Yeah, negatives.
Yeah.
So again, when we're doing this, sometimes they're a little bit harder. For example, if they're bigger, our factors are going to be a lot bigger, or there's going to be a lot more factors to kind of run through your head. Mm-hmm. But it helped that Becca said 15 and 20. I thought of some numbers that are close to 15 and 20, so 30 and 10. So we're looking for two numbers that the product is 300 and the sum is negative 40. So like as Becca mentioned, those numbers are both going to be negative. So we're going to get W minus 10 and W minus 30 equals 0. So W can either equal 10 or W can equal 30. So we have two possible solutions for the width there.
This is
Let's
a
do it.
pretty big problem. It turned
It
into
is.
something way bigger.
So you could actually have two different dimensions here and get these kind of same. So I guess I'll work out both of them. Coming back here to my perimeter equaled 2.
Use your the 40 minus W equals length.
40 minus W equals. Oh yeah, that'd be a
Yeah,
lot easier.
That
right?
might be a lot
Okay.
easier. And as you can kind of see, that's actually the W equals 10 and then the W equals 30. That's going to be your width and length. So if you were to use, for example, if you were to use 40 minus the 10 as your W, you'd get that your length
Right.
is 30.
It's 30.
If you were to use the width as 30, you'd get 10 as your length.
Okay, so that
those are
actually
just
makes
both
sense because
dimensions.
yeah, the dimensions are really interchangeable when we're talking about perimeter and area in the equation.
Yeah.
So I guess we have our length and width there then, right?
Yeah.
So our
Looks
length
like it.
could either equal 30 or it could equal 10, and then vice versa. So if our length was 30, our width would be 10. If our length was 10, our width would be 30. And so I guess Becca clarified that you really could do this either way, because when we talk about the area of a rectangle, it's length times width. When we talk about the area or the perimeter of a rectangle, we're just adding them all up. So regardless, I could reorient this rectangle another way and I can call the width the length, the length the width, get the
Right.
same answers.
And that's actually a pretty good point. There is really no difference necessarily between the definition of width and length. I've always gotten that question in middle school is which one's the width, which one's the length? And it's not necessarily the longer one or the shorter one. It just, if one's width, the other's length, and vice versa.
It works out either way, whichever one you pick.
There really is no technical difference. So, all right. Well, Nate has some math shortcuts that he would like to share. And actually, we were talking about a few of them earlier, and they are very interesting and kind of cool to know.
They're kind of interesting in how they work out, and that it ends up being pretty easy.
It's so true. It makes things a lot easier, these shortcuts. They might not necessarily be the procedure might not necessarily be mathematically correct in the sense that it will work for every scenario, but these tricks are really pretty great. So what were some of the tricks that we were talking about?
So one I thought of off the top of my head is if you give me any 2-digit number that ends in
I like
5
this one.
and you want to square it. Again, this is a lot quicker than doing this on your calculator. So if you want to give me a
Okay.
2-digit number that ends in 5, then I'll square it for you.
Okay, 65.
So 65 is going to be 65 squared is 4,225. So it sounds kind of
Did you
impressive.
really just do all that
I
multiplication?
did. I did
in
not
your
just
head?
memorize these. It's amazing. So it sounds a little bit challenging because it just comes out with big numbers. But these are actually really easy to do. I show my students all the time, and then they can show their friends, and everybody thinks they're just really good at mental math. So all I did here, if you want to look at my screen for a second, is, what was it, 65 squared?
Yes.
So really quick trick. Again, I said any 2-digit number that ends in 5. So that could be 25, 35, 45. All we're really doing is we're saying, like, take a look at this first number, 6, and think about the number that comes after 6. So 6 times 7 is going to be 42. And these are always going to end in 25 because in the end it's 5 squared. So 4,225. So really quick, easy trick. But again, if you're doing some, I don't know, I see this a lot in geometry. We're doing Pythagorean theorem. You're squaring a lot of numbers. It makes it really quick. You don't have to run to your calculator and try to punch this in really quick.
All the time. That does make a lot of sense. Okay, so 85 squared.
So 85 squared is going to be 7,225. So same idea, 85 squared. What comes after 8? 8 times 9 is 72. And then we just add 25 at the end. So I think really anybody can do this as long as you know your times table is up to 9. Do you want to try one?
Okay, so give me one.
All right, so we'll do 45 squared.
All right, so 2,025.
Right, so pretty easy, right? Lily, you want to try one?
Sure, I'm gonna need my paper for this because
All right.
that's just how I roll. Okay, go ahead.
So what about 35 squared?
Okay, so 35 squared. So you said 3 times, what was it?
The next number after?
The next number, so 3 times 4, and that would be 12. And then, oh, okay, so
Yeah.
gotcha. All right, so it would be obviously 1,225. Okay, cool, awesome.
So yeah, like a really quick trick to learn, and it saves you a lot of time when these come up.
Very nice.
Awesome.
Sounds like we actually have a caller on the line
Ooh,
right now.
callers here. All right. Hello, can you hear us? Are you connected yet to us?
Yeah, I hear you guys.
Hi, how are
Hi.
you?
Good, how are you?
Good.
Great.
What's your question for us today?
So my question is, one positive number is 18 times another positive number, and the difference between those two numbers is 170, and then I'm supposed to find the two numbers.
Okay, so repeat that one more time. You said it's 18 times.
18 times another positive number.
Is equal to.
Well, it doesn't say what's equal to, but the difference between them is 170.
So if one number is 18 times the other, so we have two numbers like x and y.
Oh, I see. So x, we could say, okay. And then you said, and then the difference between them, so is what?
170.
170. Okay. I think I got you here.
So kind of another systems.
So kind of, yeah. So what you can do is with that information that you gave me there, you can write two equations from. So the first, what we'll do is, I guess, since there are two numbers that we don't know, we'll call one of them x and one of them y. So just two different numbers, and you could call them whatever numbers you want to. But you said the first one that you said one number, so we'll say x, is 18 times the other number.
Mm-hmm.
So we could say x is equal to 18 times y, based on that information that you gave. And then the next piece of information that you gave is that the difference between the two gives you 170. So what we could then say is x minus y equals 170. So do those two equations so far, those make sense?
Uh-huh.
So once you have two equations, if you have two equations, two variables, we can solve them. And basically with this first equation, x equals 18 times y, or 18y, we can, because the x is already isolated, we can just replace in the second equation that x with that 18 times y. So we'll call that second equation, instead of x minus y, we'll call it 18 times y minus y equals 170. Does that make sense?
Uh-huh.
Okay. So then from here, we just have one equation and one variable, so we just have to get it by itself. So combining that 18y minus y, then we have 17y equals 170. And then divide both sides of the equation by 17. And that gives us that y is 10. So that means that one of our numbers is 10. And we have to find the other number. So we can pick one of the two equations to find that. And I'm going to go with the second one just because it doesn't require me to do any multiplication. But we can say x minus 10 instead of y is equal to 170. And then add 10 to both sides. And that means our other number is going to be 180. So that's one way to solve it. There are maybe a couple other ways to solve it. You could possibly do like a guess and check kind of thing. Guess one number and then multiply it by 18 and see if when you subtract them, then you get 170. But this would be, a pretty straightforward and an algebraic way to solve it.
Yeah, and guess and check sometimes, you could spend a lot of time guessing and checking, and if the numbers are more complicated.
Yeah, I actually had a question kind of like this one for my warm-up. Well, it was actually more like the area one for my warm-up today, and they all guessed it because they were easier numbers. So sometimes you can guess them, but not necessarily. So did that make a lot of sense?
Yeah, that made a lot of sense. Thank you.
Okay, great. Call us back if you have any other questions too. Thank you so much for calling.
Mm-hmm. Will do.
All right, take care.
All right, so as we mentioned before, we're sponsored by Emily Griffith. So we're going to take a moment and hear a word from both Emily Griffith High School and Emily Griffith Technical College.
There's times when you wander and ponder all the labels you've received.
Believe me, I've got a few. Never mind from when, why, or how.
'Cause now, everything's different. I found the perfect place.
A space where the labels fade and I'm accepted and supported.
Check what the news reported. Emily Griffith helps all who wish to learn.
Turn towards your future while you finish the basics on your time.
Prime opportunity in this mature environment.
The only requirement is motivation and thirst for success.
Invest in your passions. There's no limit to how far you'll go.
And know that you'll have something in common with everyone here.
We all chose empowerment over standing still in fear.
We'll start loosening up those muscles for that rub. I can't believe how much Emily Griffith Technical College has helped me personally and my career so much. They really invested a lot into me. I really felt it while I was there as a student. And I think because of that love and support, I was able to have more confidence in myself. I've been able to open a business for myself. I can do anything I want, right? And I'm not talking about my schedule. I'm talking about that I can truly give back to the community.
Hi, welcome back. Hopefully you enjoyed finding out some more information about Emily Griffith High School and Emily Griffith Technical College. There's a lot going on there. It's a great place to work. I mean, I love working there, and just a lot to offer. So
Tons of opportunities for the students over there.
that is for sure. So check us out, get some information if you are interested. So let's go over to Lily, but instead of getting a question from her, let's actually get some information.
So today we are going to be talking about our Facebook discussion, which is about robots. And this is talking about the very first hotel in Japan that's completely run by robots, which is pretty crazy in my opinion. But it says that Leonardo da Vinci actually drew up humanoid machines in 1495. And a man named Mark Roseheim, I'm not sure how to pronounce his last name, so I'm sorry, created a functional miniature version for NASA for them to explore Mars and colonize Mars. So I thought that was really interesting for sure.
So robots have actually, I mean, they have been around for a relatively long period of
A bit
time.
more limited use before, but
Right, they're now starting to develop, they're starting to become a lot more sophisticated now and a lot more, be able to do a lot more functions than the simple ones that were maybe developed before. But like I was reading about one that was built in the 5th century BC.
5th century, wow.
Yeah, and it was a mechanical bird. So I don't know if that would be.
Does that qualify as a robot based on?
Yeah, if that would be going more towards air travel
Right.
or,
Like a droid or something like that.
robotics, but it was a mechanical bird. It was a robot bird. So it was actually powered by a jet of steam or compressed air. So it was a robot.
Oh, wow. You know, talking more about the hotel, like I don't know if I personally want to stay in a hotel run by robots, but it's kind of not surprising. I didn't know there are like more than 1 million industrial robots in use now, and half of them are in Japan. So it would actually make sense that they're starting a hotel in Japan with robots.
So there's a difference, though, I mean, between industrial robots,
Right.
you know, working at like a factory or something like that, to running a hotel. I mean, that requires almost a social aspect to it, don't you think?
Yeah, they have to be able to pretend to like
Communicate
enjoy your
and
conversation.
Engage, yeah.
And facial.
Because you always see those robots putting on like the caps for the, you know,
Right.
toothpaste or whatever, but
Right.
the ones that actually can engage, that's something more like
Yeah.
studying human behavior in a way.
Right.
To realize how, I don't know, to I guess see how good robots would communicate with humans or
Kind of reminds me a little bit like Siri. I feel like
yeah.
I would end up
She's
getting
actually a
very
real
frustrated.
person.
Yeah.
You know, I said I want more towels.
Yeah.
Not pillows, towels, Siri, towels.
I could definitely see that being a problem.
So I could see myself getting pretty
I
frustrated.
just put on the male version. He understands me better.
I do the same thing. That's funny.
Yeah, there are actually a lot more uses for them though. Like, so in the military, they use them to detect roadside bombs.
Oh,
So they
yeah.
can kind of
Keeps you in
send them
safes.
ahead. Yeah,
Yep.
it keeps a
Yeah.
lot of people safe. So they've been using them quite a bit for that.
Yeah, I think I've seen those on documentaries for the Army before. Pretty interesting, actually.
Oh, we have a phone
Oh.
call. So let's take our phone call.
All right.
Are you there? Thanks for calling
Hello?
Homework Hotline.
Hello?
Hi.
Hi,
Do you have a
math
question for us?
problem.
All
Yeah.
right. That's what we're here for.
Cool. It says simplify 3 open parentheses
Okay.
5x minus another open parentheses 5 minus 3y plus 4x close parentheses plus 2y close parentheses. It's exhausting even saying the equation.
Yeah, I think my hand is hurting from writing that down.
I
Actually.
know.
Do you want to take this one, or you want me to?
Up to you. I think we both have it written. You go for it. Go for
Yeah, I
it.
can
You
take
always
this
do
one.
geometry. Go do some
Yeah, I'll do
algebra.
it.
Somebody please help me.
All right, that's what I'm here for.
We'll have Nate help you.
Can you actually? Are you watching right now?
I sure am.
Can you look at my screen and tell me if I got down what your problem looked like?
Yeah, that's close enough.
Close
Let's
enough?
Just
All right.
bang it out.
All right, so we'll go with this then. So when we're doing this, again, when we're simplifying, like, obviously this needs some simplifying because it took you a while just to even say it all, right?
Yeah.
So what we're doing is actually we're going back to our rules of PEMDAS, and we're going to have
Okay.
to apply this a couple times. And do you remember what PEMDAS means?
PEMDAS, parentheses,
Yeah.
and then, so on and so forth after the parentheses
All right.
part.
All right, so we'll start with the parentheses. That's a good start, and we have a couple layers of parentheses here. So what we're going to do is kind of start on the inside and work our way out. So what I'm going to do is I'm going to leave everything else alone, and I'm going to try to simplify, basically try to get rid of the parentheses right here. You see where I'm kind of boxing this in?
Mm-hmm.
So what I need to do, actually, I'm going to leave everything else alone. So I'm copying this 3 times something. I'm leaving the 5x alone. Now this negative, I need to distribute this to every term inside the parentheses. Does that look kind of familiar?
Mm-hmm.
Okay. So if you think of this as this negative as like a -1, that kind of like the 1 is not visible. Really what we're doing is we're multiplying everything by a negative. So 5x, I got -1 times 5 is going to be -5. And then I'm distributing -1 times -3y. That's going to be a positive 3y. And -1 times positive 4x is going to be -4x. And again, I'm not touching this 2y at the end, so plus 2y. Is that all making
Okay.
sense?
Yeah.
All right. So this looks a little bit more manageable. There's still a lot going on, so we're going to continue simplifying. So when we talk about parentheses for this p here,
But I think I know what PEMDAS now means now.
Okay.
Excuse me. So is it parentheses, exponent, multiplication, division, addition, subtraction?
yeah, that's absolutely correct. So we're kind of just,
Booyah.
all right. So we're working through it in that order, right? So what we have here, again, I'm trying to work through this kind of mess right now. So everything inside the parentheses, I want to simplify. So I'm going to highlight really quick. Everything inside here, I'm now going to simplify. Right?
Okay.
So all I'm going to do that is leave this alone again. And I want to combine all of my like terms. And again, this gets a little confusing because there's just a lot of terms in here. There's a couple variables. There's some numbers. So it's really easy to just miss stuff here.
Uh-huh.
So what I want to do is I want to think about a way that I can make sure I'm not missing anything. So I'm going to go from left to right, and I'm going to say, okay, I've got 5x. Do you see anything that you can combine this with?
The other x, the 4x.
Yeah, the other x. So I'm going to make sure I'm including this negative because that's part of it.
Okay.
So 5x minus 4x is just going to be x. So
Okay.
what I like about doing this is I boxed them so I knew which ones I was using. Oh. So I'm going to cross these out because I've now already kind of covered these, right?
Uh-huh.
And we don't want to double count anything.
Uh-huh.
So lucky for me, I have all these different colors, so I can do this a little bit differently. But I'm going to show you if I were doing this with like a pencil, and I didn't, I would just go ahead and circle -5, right?
Okay.
And if you take a look, there's nothing to combine that with.
Uh-huh.
So -5, and I'm going to just cross that out, because now I'm done with it.
Okay.
Now, what are the last two terms I have left?
You've got the 3.
Okay, the 3y, so I'm going to circle that.
And then, I don't know. It's honestly kind of hard seeing with my glasses right now, but
Yeah?
I know we've got the 3y, and then what about the 2y?
Yeah, so we got that 2y there. We can combine
The
these.
negative, it's a negative 3y still, though, isn't it?
Is it negative? Oh, so if we look back here, actually, can you see kind of what I'm drawing an arrow to?
Yeah.
This -1 was multiplied by the negative 3y.
Okay, that's right.
Yeah, so that became a positive.
Okay, cool.
All right, so 3y plus 2y is going to be positive 5y.
Y. Yep.
Right? So now if I take a look at this, only looking inside the parentheses, is there anything that I can simplify there?
I don't think so.
Yeah, it looks like I'm kind of done with that.
Yeah.
I've combined all my like terms.
Yeah.
So if we walk through this, I can think about this is done. The exponent, are there any exponents here?
No.
No, I don't see any. So we're going to skip ahead to,
He didn't sound very sure. Are you sure about that?
You know what? I'm just letting Nate lead me through it.
all right, so when we're looking for exponents, we're looking for any, I'm going to give you an example. If I had like x to the 3rd, and then I had this to like the 2nd power, we might need to do that before we do anything else.
Yeah.
But we don't have
That's
any of that.
PEMDAS.
Exactly. So I got a lot of dots here. So now I'm going to go to multiplication. So I'm multiplying again, so 3 times x is going to be 3x. 3 times -5 is going to be...
Negative 5x, or negative 15x?
Oh, just -15, right? Because
Oh.
I don't have any variables here.
Oh.
You got it, though. Just a little
Okay.
practice. And then we're lastly distributing 3 times 5y. All right, how about this one? It's 3 times 5y.
3 times 5y. It's just 15.
15, and then you don't want to leave that y out, right?
15y.
Exactly.
Yeah.
So does this look a little simpler than what you started with?
Definitely. I can definitely say that one a lot quicker now.
I'd hope so. So this is simplified form. All we're doing is kind of combining everything to a simpler form. That's why it's called simplifying. Did that help?
Awesome. It helped me so much. I really appreciate what you people do.
Great. Thank you for calling.
Bye now.
Thank you.
Bye.
Call us back if you need to. All right, so it's that time again. We're going to give you the trivia question one more time, just in case you missed it at the beginning.
All right.
Again, call us if you've got an answer. Phone number on the top right of your screen. The question is, what group of animals, other than humans, are capable of hurting other animals and are capable of farming? So if you think, even if you think you have an answer for that question, give us a call at that phone number on the top right of your screen and you would be eligible for a prize.
Yeah, and remember, we're not going to take a prize from you if you guess wrong, so feel free to give us a call and throw a guess out there.
No harm in guessing.
Name an animal.
Might as well. Might as well. All right, well, let's see if we can't get more trivia, or not trivia, I lied.
Social media, maybe?
Social media. Let's get more social media questions answered.
Okay, so it says how do I solve this quadratic inequality? And it says x minus 1 and parentheses x minus 5 and and parentheses, and then it says greater than 0. So.
Okay, I think I got you. And I'm going to refer back to, we did a problem kind of like this last week, I think.
I think it was last week.
It's a little bit of a pre-calculus question, so I'm going to be speaking a little bit upper level math, but basically if we had this as an equal sign, what we want to find out is what x would equal if this were an equation first. And what that does is it gives us basically some benchmarks to test intervals of what would actually make x true. Because in inequalities, our variables are not necessarily just one answer, it's an interval of answers. So first we're going to find out what x is if this were equal. So what we do is we could set each factor equal to 0 and solve. And what that would mean is that x would equal 1 and x would also equal 5 if this were an equation. Now it's not. We don't want to know where this is greater than, or sorry, equal to 0. We want to know where it's greater than 0. So I'm going to draw a number line to kind of demonstrate what I'm doing here. So here would be 1, here would be 5. And we're going to draw open circles on those because that doesn't actually equal 1, doesn't actually equal 5. We want to know if it's going to be something less than 1, something in between 1 and 5, or something greater than 5. So what we're going to choose is test numbers to plug into our inequality to see which numbers in what intervals make this inequality true. So I'm going to choose 0. That's a nice one to choose. So something less than 1. Then I need to choose something in between 1 and 5, so let's just say 2, and then something greater than 5, let's say 10. So these are the 3 numbers I'm going to test to see if it will make my inequality true. So let's go to the inequality. Let's start with 0. So 0 minus 1, I'm replacing x, times 0 minus 5, and we want to know if that's greater than 0. Well, 0 minus 1, that's a negative number, times, and then 0 minus 5, that's a negative number. And we don't even actually have to find out exact numbers. We just need to know if it's greater than 0 or less than 0. A negative number times a negative number is going to give you a positive number, and that a positive number is always going to be greater than 0. So stuff that is less than 1, like 0, that's going to make our inequality true. That'll work. Let's try 2 now. So we'll put 2 in here. So 2 minus 1 and 2 minus 5 greater than 0. So 2 minus 1 is going to be a positive number. 2 minus 5 is going to be a negative number. A positive number times a negative number is going to give you a negative number. A negative number is not going to be greater than 0. So this does not work. So numbers that are in between 1 and 5 are not going to make our inequality true. We have one more interval to test, and that is numbers that are greater than 5. So we're going to use our 10 to test that. So 10 minus 1 times 10 minus 5. And 10 minus 1 is a positive number times 10 minus 5, also a positive number. A positive times a positive is still a positive number, which will be greater than 0. So we're also saying that numbers that are greater than 5 should work for our inequality. So now the last step that we have to do is we just have to write this in interval notation, which just means that we are writing our answer in a form that would actually, it's not just with a picture, it's with numbers. So we would say anything from negative infinity all the way till 1 is going to be a solution to this. So x could be anything from negative infinity to 1. And we're going to put a parentheses because it's not actually going to equal 1. If it were to equal 1, I would put a bracket. So, oops, sorry, I'll show you what that means. A bracket like this. But it doesn't equal 1, just greater than, just less than 1. So a soft parentheses. And then also we have anything from 5 all the way to infinity is going to be a solution as well. So this would be the solution to that inequality. So I did just kind of explain some pre-calculus concepts pretty quickly, so if you do still have some questions with that, let me know. But hopefully that helps you get to what you need.
Yeah, I remember when I taught pre-calculus, students would always ask when they're testing, like, what number should I pick? And it was
0.
like, yeah, just pick the easiest number that you can
Yeah.
that fits those rules. It makes it, like, there's no reason to make it harder on
So
yourself.
anything less than 1,
Yeah,
0 is always an easy one.
0 is always easy.
Always
and
easy.
it sounds like we have a caller that wants to guess the answer to the trivia question.
Ooh. What is
Hi.
the answer? What do you think it is?
Is this the homework help hotline?
It
Yes,
is.
this is.
Okay, very good. Could you repeat that question for me just so I can make sure I'm on the right page?
Okay, so the question again was, what group of animals other than humans are capable of hurting other animals and are capable of farming?
Well, I was originally thinking dogs because I know that they do herd.
I was too.
But the only animal I've ever heard of that farms other than humans is ants. Is that the correct answer?
That's actually correct.
That's our correct answer.
Oh, that's so great to hear. Do I win a prize?
Yay!
You do.
Yes, you do.
That's awesome.
Absolutely. So somebody behind the scenes, they'll talk to you in just 1 second and they'll get you set up with your prize. Thank you so much
yeah,
for
thanks for
calling.
calling.
I'm
Great
so
guess.
excited. Thank you so much.
Congrats. Yay. Awesome. So we have a winner to our trivia. So
All right.
you guys see now if you call in and get the answer, you get rewarded for that.
It's funny, I actually thought dogs too, but then
I did too.
I saw the and are also capable of farming, so
Yeah.
that kind of throws it off a little bit.
I like how he explained that too,
Yeah.
because I thought the same thing. I thought, oh, dogs can herd, but then
Right.
I don't think they could farm.
Not that I've seen.
Pretty
My dog
short,
can't, at least.
yeah. I know, yeah. Awesome. Well, great. So that's what happens when you answer the trivia question. So, let's talk about ants a little bit. Actually,
Yeah, we actually talked about them a couple weeks ago, but they're just really fascinating. So there's plenty to talk about.
Oh, I remember I did in 4th grade. I made like a magazine as one of my projects about ants.
an
It was like a
entire magazine?
report. Yeah, it was like a magazine
Wow.
cover, I think, and then I made a couple articles about it. But I remember that they live a long time without their head.
Really?
Yes, kind of like cockroaches.
How long do they live?
I'm not sure.
You
I
haven't
don't
tested
remember,
it?
but I just remember that from 4th grade. They also don't have ears.
Oh.
So they can't
Oh.
hear. They can farm, but they can't hear.
Oh, okay, so they don't hear anything. Is it mostly like sense?
Right. They just kind of hear through vibrations.
Oh, so like
it's
in the
not really
little ant
hearing,
feet?
but that's
Feeling,
kind of how they
mostly.
do
Okay.
it. Yeah.
I think everybody also always talks about how strong ants are and like comparisons to humans. So I was reading, they can lift 20 times their own body weight, but if a 2nd grader was capable of like the same relative strength, they'd be able to pick up a car.
Oh my goodness.
That would be
2nd
kind
grader.
of terrifying as a teacher.
So Superman is
grader's son
basically
cars.
like the movie human version of ants.
Pretty
'Cause
much.
he can lift up cars.
And you know what though, too, when
like
they
an ant.
fight, so I was just thinking about that. I'm like, oh, I wouldn't want to see them in a fight.
yeah.
But so when they do fight, they fight to the death. So when they fight, one of the ants is a goner.
So it's
the
like
most
take no
part.
prisoners kind of thing.
Yeah, no, they don't really do that.
Oh, that's interesting.
Yeah. They also, other thing that's interesting about them is when they're foraging for food, so when they're out looking, they leave a pheromone trail so that they know how to get back.
I was always wondering that because I just figured they could just walk any direction, and it's kind of amazing that they have
always
any
can get
kind of
back to
guidance,
where
really.
to where. So they do. They know. They know where they've been.
Yeah, I was
based on
also
that.
actually reading because you see so many ants around. I'm like, where are all these ants coming from? But one queen ant can live for several years. Actually, I didn't think any insects live that long. But an individual queen ant can have millions of babies.
Millions.
Yeah, and if the queen dies, the whole nest dies because they can only survive like a few months after the queen dies. So it's pretty
Wow.
crazy. Yeah, they pretty much depend on their queen. So it's pretty
Is it
crazy.
just one queen per
Yeah.
antvil?
I believe so.
Very interesting. All right. Well, we are always doing interesting things on Facebook. Yeah, check us out on Facebook and get your questions in on Facebook and Twitter for tomorrow if you've got any that weren't answered yet today. And thank you so much for joining us. You can catch us again tomorrow on Wednesday from 4:30 to 5:30 live.